everyone. Thank you for coming to my Pyohio talk. Uh, Let me know if the microphone is too loud or not loud enough. I would like to start. I hope all of you are interested and excited to learn about better curation for your code. So as you understood, my name is Ian Zelikman. I work at the Federal Reserve Bank of Cleveland, so I live in Cleveland, not too far away from here. I've been doing software development for about almost 15 years now. A lot of it in the Python stack or organization that used a lot of Python. A little bit less recently at the Federal Reserve, and I tweet at IZCoder, and that's my 4 months old daughter over there. Yeah, a little bit ahead of myself. And if you can see, I'm a little bit less tired in this picture is because she's sleeping a bit better now. So let's start with the talk. So I want to start with this nice video. Some of you might have seen it already, might be new. I used to play a little bit of Mario when I was much younger, and you can do these custom Mario levels now. I found this one really awesome, where you have to have Mario go through this impossible thing. And my question to you is, does this look familiar? Have you ever felt this way writing code? If kind of navigating through this impossible maze, anyone wants to raise their hand. I definitely felt this way. Okay, for the people in the video, looking the video, a lot of people raised their hands. So the motivation for this talk is basically how you can look at your job, at your day-to-day work, so that developers coming after you or people working in the same code base are not going to feel this way, basically, and make their jobs and ultimately your job a little bit easier. So let's get started. There are a few statements that, as I was working with code on different projects, longer, shorter projects, bigger, smaller system, these are statements that I came to know is true, and some of them might be very familiar to you. So the time we spend reading code is very often, I would say almost always, is much longer than we spend in writing that code. The time that we see that code actually existed is much longer than originally we thought that the code would exist. I don't know if it would sound familiar to some of you. You go ahead, you write some feature, you think you're going to rewrite it or address some issues later on in the next sprint in a few weeks, and then 2 years later, that code still exists there. I definitely, as I was writing this slide, I thought of a few cases that, yeah, definitely 2-3 years afterwards, some of that code that I thought would only live for 2 weeks is still there. And then this is very intuitive. The time to update code is much longer than it was to initially write it, because once you have a feature implemented, you have users using it, you might have some other code that's dependent on it. You have to do much more investigation into rewriting something. Even if it's something very trivial, it is going to take you longer than it was originally writing it. So investing the time into making the code more maintainable and adopting this framework of curating your code and being the person that the code basically was entrusted in, I feel very strongly about. So you'll see as we go along this presentation, it's a very opinionated presentation. I hope you'll find that receptive. So these days, if you want to define something, for example, a curator, you go to Wikipedia, at least that's what I do as a first thing, and check out what's the definition over there. So a curator is a manager or overseer, traditionally a curator, keeper of cultural heritage for a gallery, museum, library, and is a content specialist. And it's someone that is charged with the institution's collection. And I will come back to that word, the collection, quite a bit, and involved with interpretation of heritage material. So I like to see the code that I'm working at, whether this is a project that I started or that was started before me, as something that was entrusted to me to keep in good health. And for me, in good health is basically maintainable. And something that other developers, as they work on it, they find it something enjoyable to work. So that's how I like to approach it. I want to emphasize basically this is a shift from viewing your job as implementing new features, making a shift to actually thinking, no, it's not only the important on the new functionality or the features, it's also on maintaining the health of your code. And that's what this talk is going to focus on. We're going to see several ways of maintaining that code health, that some of them might be familiar to you, some of them might be new. And that's overall as kind of a package of how we keep maintainability and the health of our code. So style guides. I think we briefly heard about the style guides at the keynote this morning. I wanted to start with style guides because I feel they're important. Style guides are a set of guidelines or rules that we agreed on to write our code adhering to those rules. Why are they important? Ultimately, the job of creating code is personal. There is many ways to achieve the same functionality, and each person is going to write it somewhat differently. Style guides help us to make this into a cohesive framework, a cohesive code that would make it easier for our team as a whole to read it and have a much easier mental image in their head when they're trying to read it, and they have an easier readability. A few points I wanted to stress on style guides is you should agree on what works for your team. So a great example, probably in this room for this conference, is PEP 8. Is basically universally agreed as a Python style guide, but it might not be 100% applicable for every project. You might have a project that has some C code along with a big Python project. You have some C extensions. So you might want to adopt some of the PEP 8 guidelines or update them to have additional guidelines to accommodate the C code in your project. I used to work on a project that has a lot of SQL inside of the mainly Python project, so we adapted some style guides for alongside for the SQL with the Python stuff. Another part is PEP 8 is opinionated about the character limit on the code lines. You might want to adopt that. Different teams will feel differently about it, and ultimately it's more about what fits for your team and not what you have to follow blindly because that's what someone on the internet said. Conventions that go beyond style guides. So style guides are nice, but I feel there is another level you can go beyond that, and that is adopt conventions. Conventions can be something like you agree on a certain way to write your conditionals. You want to always have or strive to have positive conditions. You want to have them maybe going in a certain style. You want to have certain limits or certain ways that you write methods around. So that might be different conventions that you discuss with your team and you agree. Those would make sure that when someone writing one feature, it kind of fits in together with other features and enables people farther along to being able to jump from one part of the code to another and more easily to read that. And for me, the most important part about style guides is that styles should be explicit. When you go to a museum, you go to a gallery, the rules are kind of very explicit to you. You know if you may or may not be able to take pictures. You know when to be in quiet rooms, to remain quiet, things like that. If your style guides are not explicit, you can't blame the new maintainers or first-time or one-time maintainers about not following those style guides. So what's more important than having a style guide is being very explicit about it so that people can very easily know it and cannot be blamed, because usually people want to do the right thing and follow the style. They just need a very clear place to know what it is. Testing. So testing, obviously, very important. I think there are a few testing talks, and I believe there is a testing tutorial in this conference. Definitely recommend checking it out. And you should do testing earlier and not later, as in this Dilbert comics. But I actually wanted to talk about another aspect of testing. And I see testing as a way to document your code. So when you write code, and then the other person after that, after 3 months going to read it, it very well might be you. They don't necessarily know what was the reason you wrote it. Maybe the reason to put all those obstacles to Mario, there was a good reason for it. But because the person reading that code doesn't know about it, they become frustrated. Now, I like to leverage tests in this way. When you write tests, you need to have a name for your tests. The body of the test ensures that your code is actually correct. But the machine reading that test or that name, the machine doesn't care really. That is something that is for you that you can utilize to use better. So the first name that you might write naively is test function code with args, but I don't really need that name. I can just read through the test, and I can see that there is an assertion there that is making sure that this function was called with certain arguments. What I'm really trying to make sure with that test is that the first name that was supplied actually has more than one character. That's what my code ultimately wanted to implement. And that makes it much easier for people not to struggle understand why why you implemented this feature or why you implemented this way. The name documents it basically for you. It makes them easier basically jump through that hoop very quickly. Another feature, maybe you have a class named pen in your code. And then maybe your testing framework supports classes of tests. So I would recommend, instead of going and just creating a class test pen, instead of that, group your testing into features that the class actually supports. So my pen can draw different shapes. So I'm going to create a class test draw shapes, and there I will have test draw rectangle or test draw triangle. And very similarly, if my pen can draw colors, I would put in a test color class, and I would have draw red or draw blue, something like that. So that gives you a very good documentation of the code. I would like to make the analogy of basically having those plaques you see next to in an art gallery or a museum next to an art, and that kind of gives you the idea what was the intention of the art. So that's how we go along with that curation analogy. The other part that helps for our documentation is commit messages. All of you probably are using some kind of a version control. If you don't, you probably should. And a lot of times it might be Git, but it would have commit messages. So I'm sure a lot of us have done this, where they put in a commit message saying updated class pen, but I don't really need that as a commit message. I can just go in and see what the changes were. I'm much more the commit messages that really convey the intent and how the code was written, is if they are, and enable me not to have to go and read all of the changes, is having it much more descriptive. So I would write add ability to draw with the different colors. And then as you have different commit messages, as they go one after another, you can kind of just, instead of looking through different revisions in the code, you can scroll through those descriptive commit messages, and you can see how basically the code evolved, how different features came in, they came out, and that gives you an insight into how your collection of code or the body of code evolved. Some places you might put an issue tracker number. It's as part of your commit message. Some organization make that as obligatory or as an option. I kind of have a ambivalent attitude to it. On the one hand, it gives you another reference to in the issue tracker to be able to see where the requirements came from. On the other hand, you end up with like 10 commit messages, one after another, all of them referencing the same issue. That becomes a little bit tedious. So again, you would do what makes sense for your team so that your team would be happy about your code curation. Team discussion. So as we mentioned before, curation is important, and a lot of times developing features is challenging. A lot of our work is challenging. So I like to have discussions with different members of the team early and often. A lot of times you have people in the team that implemented different features. Someone might be familiar with the back end very much, and someone might be very familiar with the front end. And in order to create a way where all the code kind of fits together, where you are better curators, you need to understand how it fits the new code that you're writing, how it fits in the overall image. So discussing it with different team members, maybe discussing it with team members that left and went to be on other teams, I feel is very important to achieve that goal. So that's why I recommend doing team discussions and maybe getting this end of, wow, this problem is really hard. The Boy Scout rule. Some of you might have heard about the Boy Scout rule. The Boy Scouts have this rule that as they go to a campground, after they leave it, they try to leave it in a slightly better shape than what they found it. A lot of people adopted that rule for software engineering. Basically, leave the code in a better state than you have found it. You might not get to this very nice campground right away, but as you do small changes each and every time, eventually the goal is to get to this level, and again, being better curators with the code that was entrusted to you. So a few examples of the Boy Scout rule, and you can find a lot more, and you can come up with a lot more of your own. You might have a code base that has a lot of style issues because it was implemented before you agreed with your team on a style, or the style changed over time as the team matured or the team changed. So fix style issues. As you go and you work on a new feature, you need to change some class. Fix the style for the entire module, for the entire class, not specifically those lines of code that you are touching. Add or remove documentation. Today you might have been working on some feature and it took you 20 minutes to understand what the function is doing. If you just add one line of documentation, the next time someone needs to understand that function, they would be way less frustrated if that documentation is there, and they actually don't need to spend those 20 minutes. So again, it makes it easier to run through that code. And another small thing that I like to have is, and to do is they use meaningful names. I think it makes a huge difference. And if you see variable names that are one character or really don't make sense for that code anymore, maybe in some prior iteration, that variable name made sense. Now it doesn't. Just changing the variable names makes a huge difference for the readability later on and has people less frustrated. And the refactoring. So keep calm and refactor. What is refactoring? Refactoring is the basic action of updating your code without actually changing the functionality that code comes to implement. It goes a little bit beyond the Boy Scout rule, at least for me, because with the Boy Scout rule, you're only updating the code that you're currently working on. With refactoring, you're actually seeking code that maybe has become a little bit stale, maybe hasn't been updated for a long time. now people are less familiar with it. They're basically becoming not as good curators of their code because now people are actually starting to be afraid to touch their code because no one is familiar with it anymore. So you should go proactively and refactor that code to make it better. For example, a great example of that is if you start to see in the code a group of variables that you're constantly using together, 3 or 4 variables, that usually gives you the hint that those variables can be grouped into one class, and you can start using them more easily that way. Usually, once you create that class, you also find the usage for some method you can add in there, and would simplify that. Then you can go in and split functions, make them, it's always nice to make a function that grew too much to make it smaller. It still serves the same functionality, but now you split it into 2 or 3 functions, and it makes it easier to read it. Now you updated the code, you become more familiar with it, even if you didn't originally write it. And as people do code reviews, they're also familiar with that code because they've seen that you have just changed it. So all of us who are curators of the code in the team, they are becoming better curators. And something I like to do also is redo conditionals. So if you see 4 or 5 if statements, one after another, usually you can simplify that to have only a few if statements. It makes it easier to read. It makes much more sense usually. So redoing that doesn't really change the logic. I actually remember doing that the other day where I saw code that was written with like 4 if statements, and then redid it, I think, into one if statement that was a little bit longer than the original ones, but actually was much easier to read. Less is better. So this is where the analogy to traditional curators might be falling a little bit, falling apart, because traditional curators, they grow their collection. Part of their job is to grow, make their collection bigger and better. In our case, for code, it's easier to have code maintainable and better if you have less of it, right? You have less things to maintain. So you can focus on the other parts. So as you have code that implements functionality that you no longer need, just remove that. It would always be there in version control, or it will be there for a reasonable amount of time until you switch to a new version control. And then it would also, you just don't need it anymore. You're able to focus on other stuff. If you have a large portion of your code that now is actually, there is an open source library that can be implemented, just refactoring, start using that code library. That is something that you no longer need to maintain. You can focus on the other functionality that's actually important for you. And the last one is keep it simple. That might be like the most simple and the most important one is as you keep your code more and more simple, as you only have like this one trap for Mario that's is a very good trap, but it's still only the one, that's where you're becoming good curators and you enable the readability for it for future developers. So those were the set of kind of a tool set for you to become curators. For me, it's not necessarily about those individual tools. It's more about enabling you to think about your job as not focusing, as I said in the beginning, on individual features, but overall, as you go and maintain the code, curating it, and taking care of the code that was entrusted to you. I want to finish with this quote from Martin Fowler, which I really like, and I heard different variations of it, is a lot of times the challenge in software engineering is not necessarily writing code that the computer can understand. A computer would understand if you write code in very different ways. I see my challenge as a software engineer in writing good code that other engineers would understand. That's where the challenge lies. So I think we're about in time. Thank you very much. Thank you to the Pyohio organizers and the volunteers we have around here. If you want, I have a little bit of a survey feedback that you can fill out. And I'll be around for any questions in the hallway or wherever you want to find me. I would like to talk more about this topic. Have a great Pyohio.